Good afternoon, everyone. My name is Aida Manzano, and I am the academic representative of the final year cohort of design engineers at Imperial College Dyson School of Design Engineering. My name is Aida Manzano, and I am... It is my pleasure to welcome the distinguished representatives of the 11 companies tonight that have early access to a cohort of highly skilled design engineers ready to enter the industry market. This event is a great opportunity for companies and students alike to network and make important contacts and allow you, the companies, as well as the students, to get hired from a world-class institution that they are about to complete their studies in one of the most novel and cutting-edge degrees that exists. I would like to thank Pooja Sonaji, Max Hunt, and Melissa Mukovic for helping bring this event to life, and also Dr. Talia, Dr. Eva, and Dr. Stephen for their support and guidance. Without further ado, I will kick off the first half of the careers fair by presenting our first keynote speaker. His name is Pete Harrod. He is the Director of Functional Safety of the CPU Group at ARM. ARM is a British semiconductor and software design company whose primary business is in the design of CPUs. Over to you, Pete.
Well, hello everyone. I'm really pleased to be here and to have this opportunity to tell you a bit more about ARM. It's the company that 12 of us started 30 years ago from a barn outside Cambridge, and which along the way has developed technology that really has changed the world. We now have around 7,000 employees with offices in many countries. And actually, I would really have been happier to have been there in person to talk to you in your fantastic building in the old post office. I'm a visiting professor in the EEE department next door. Your head of school, Professor Peter Chung's my academic champion. And ever since I gave my last lecture in person in the department back in March, I've really been missing the place. So what can I tell you about ARM? If you haven't heard of us, you will know us because today you're very likely to have used ARM technology many times, perhaps even without realizing it. Your smartphone's very likely to be ARM powered, so are your wearables, your smart TV, the heating controls in your home, say the microcontroller in your washing machine. In fact, our technology is all around you. So actually ARM is everywhere where compute happens, from the tiniest microcontroller CPUs that just sip energy to powerful CPUs that run the smartphones and even servers. And we're now at a very exciting time, what you might call the fifth wave of computing, where the power of AI and machine learning, 5G data networks, and the Internet of Things will converge to make truly amazing products and services possible. And we want to play our part in harnessing this technology to address some of the big challenges facing the world, like achieving net zero by 2050. As Bill Gates said recently, solving the current pandemic will be easy compared to that 2050 goal. So at ARM, we're committed to a more sustainable future, and we really fully support the United Nations 17 goals you can see here for sustainable development. There are opportunities to work with our partners on groundbreaking technology to address these. And here are just a couple of the success stories. The Amplio talking book, for those who find it hard to access information, and SimPrint here, a fingerprint ID scanner, which enables medical records to be kept even in the remotest parts of the world. So I think the best way to make it a great future is to invent it ourselves. And so what do we look for graduates in ARM? So all the usual things that you'll see listed here. I'm sure all employers will be looking for these kind of things. But in you guys from the Dyson School, with your creativity, your innovation, your enterprise, thinking outside the box and pushing boundaries, you can do big things together to make the world a better place. So there are lots of great graduate opportunities at ARM in lots of different divisions and disciplines. Here's the link to find out more. So do come and talk to us in the ARM breakout room on Teams at 6:30. See you later. Thanks.
Thank you, Pete. Wonderful talk. It's a very inspiring company to see that it's lying at the intersection between STEM, sustainability, and social justice. This is exactly what we learn about in design engineering, and it's very inspiring. Our next guest will be Matt Johnson, the CEO and co-founder of Bear Conductive. Bear Conductive makes conductive paints and electronic hardware for engineers, designers, and artists. Glad to have you here, Matt. Over to you.
Great, thank you so much, Ada. And it's very flattering for me to be able to follow Dr. Harrod and ARM. We are a company at the other end of the spectrum, so we're just getting started. And I want to tell you a bit about what we do, and then of course about what we're looking from graduates, what we're looking for from graduates, and also the kind of approach that we take to our work and what it might be like to work at Bear. So as Ada said, we do a few things at Bear Conductive. We create smart surface technology, we empower a community of creators, and we build partnerships. So let me take you through that. So first, we have a couple of core pieces of technology that we've built. The company was founded around an electrically conductive ink. We've since built electronic hardware that allows us to turn that ink into a sensor in a few different modalities, but really we tend to call this smart surface technology. We can do a lot with these products. Fundamentally, the electrically conductive ink is as it sounds. It is an ink that conducts electricity. This is about a $3 billion market, but we were the first people to put conductive ink into the hands of engineers, designers, artists, and that has driven a huge opportunity for the company. We use our hardware to turn the ink into a very low cost, but reliable and precise sensor. So here we're looking at a very simple capacitive sensor demo. We've taken this basic functionality and put it into lots of surprising places. That's the core of this smart surface technology that we're building. Our community does things that we would never expect with it. So you may know us for some of the exciting projects that are really visceral and visual, like interactive walls, which I'll show you in a second. But what you might not know is that people are constantly bringing us new use cases. And in fact, we're in a very privileged position to be able to see the future of printed electronics technology in a way that other companies likely don't. So it's a very exciting position to be in. We have projects that are range from very simple to very complex. This is one of my favorites, a projection mapped interactive wall that was exploring the idea of the kind of future of retail. But in fact, the core functionality that we see in this wall is now being deployed in projects that we're building with much larger partners in much more kind of sober applications. But I think what I would want you to see here is the exciting collaborative nature of the technology. For us, it's not enough to understand material science and conductive ink or electronics. We also have to understand mechanical engineering. We have to understand a bit about civil engineering. We have all of these places that we have to touch in order to integrate our products into our customers' products and into their work. We're building partnerships with large brands, and in fact, this year we're going to be creating a second brand that's focused solely on smart buildings around water leaks, occupancy sensing, and touchless interfaces. We have some awesome partners on board. We're going to be announcing a lot this year, so it's definitely an exciting time to get involved with what Bear is doing. As I said, we're just at the beginning of our journey. So what do we look for from graduates? Well, if you're going to come work with us, this is probably where you're going to sit. We have a fantastic workshop that is in central London. Right now, we're not in there as much as we hope to be, but hopefully soon we'll all be back in with our hands on the tools. We expect you to be in the workshop making stuff with us. That is the core of our practice, really putting our hands on the tools and on the materials. Specifically though, we really want people who have a deep technical interest. We want you to be super, super passionate about some aspect of what you've taken from Imperial. We want you to be a massive geek about it, and we want you to infect the rest of us with that enthusiasm. We also want people who have a vision for what they want to become. You know, if you want to come and work with us and you say to me, I want to work with you for 3 years and then I'm going to start my own company, that's awesome. That's what we want. We want people who are going to drive us. We also need people who have the ability to apply their skills to a new set of problems and are excited about that. What is Bear like? What is it like working here? It's collaborative, it's intense, it's fun, and most importantly, it's very independent. And I think that really sums up everyone here today, and it will sum up the people that we bring on board in the future. So I look forward to seeing you in the breakout room in a few minutes. Thank you very much for your time.
Thank you, Matt. That was a wonderful speech. It was very inspiring to see the innovation and the creativity, as well as the intersection with science and technology. I think it's very on brand with design engineering, and it's a pleasure to have you.
Well, thank you for having me.
Our next speaker is Joel Altsfeld. He's a distinguished engineer of the emerging technologies and incubation at Cisco. Cisco develops, manufactures, and sells networking hardware, software, telecommunications equipment, and other high-end technology services and products. Thank you so much, Joel, for joining us today. It's a great pleasure to have you here, and I'll leave the floor to you.
Great. Thank you very much, Ada. So COVID has accelerated societal change and business change. Right? We've seen this rapid transition from workplace to working just about anywhere. And Cisco's been at the heart of that transformation. And it's these changes which are really forcing us to take a step back and think about, well, we don't have to do things the way that we've always done them. Right? At Cisco, we work with many of the largest organizations, both public and private sector around the world. And the question that's now being posed in many of these institutions isn't how will things go back to normal? The question is much more, what have we learned and what are we going to do differently now? So Cisco was involved in the project to build the hospital in London, the Nightingale Hospital, in record-breaking time. That whole hospital was brought online in just 9 days, start to finish. Right? Couldn't be done before. Well, now we just proved that it can be. And working with one of the largest global logistics providers, their CIO told me recently that they were forced to take a 3-year digital roadmap and execute that in 9 months. And that's a massive challenge for any organization. They had to take a globally distributed, predominantly manual workforce and introduce completely new digital processes, as well as social distancing regimes, while all the time trying to keep all these goods flowing around the world. We've seen education having to go online, as I'm sure you have all experienced. And what we've also seen is this idea that everyone has affordable internet access, even in developed countries like here in the UK, is just plainly incorrect. But how can we take the communications infrastructure and the resources that do exist and address this gap? And I'm very fortunate to be serving on the Industrial Liaison Committee for Dyson School of Engineering. And I'm quite proud to have kickstarted a small project with a small team here at the university to look at this digital poverty and look at how we can try and apply alternative approaches that might just work. So just to quote the famous science fiction author Arthur C. Clarke, new ideas pass through 3 periods. First, it can't be done. Secondly, it probably can be done, but it's probably not worth doing it. And finally, I knew it was a good idea all along. So Cisco is looking for people like you, people who can apply their skills, their thinking, and people who are up for this kind of challenge. So thank you. I look forward to talking with many of you later this evening. Ada.
Thank you, Joel. That was incredibly inspiring. Cisco seems to be the embodiment of facing challenges and facing them efficiently and reinventing yourself in a time of pressure. And I think that's definitely something that I'm very inspired by and I respect greatly. So it is a great pleasure to have you here. Thank you so much, Joel.
Thank you.
Our next speaker is Jack Travail, a graduate design engineer at Dyson. Dyson, as I'm sure you most know, is a British company that designs and manufactures household appliances and also embodies innovation in a very spectacular manner. Thank you so much for being here with us today, Jack. I will leave you to speak.
Thank you. It's a pleasure to be here this evening, and thank you for joining. So I'm a graduate design engineer at Dyson. I was in your seat this time last year, so I know what it's like, and it's been odd kind of changing with COVID. So it's great to be on this platform to talk to you today. So Dyson is, as mentioned, it's really all about innovation, invention, and it's a really great place to kind of work and learn as a graduate. I've been at Dyson for 6 months now, and I've learned so much, and the opportunities are fantastic. So I just thought I'd talk to you a little bit about some of the stuff that I end up doing, some of the kind of opportunities, and kind of what Dyson gets up to as well. So we've heard other stories about how COVID's impacted everybody, and just as kind of a bit of an example, when the kind of outbreak happened and the case of ventilators running short was kind of presenting itself as maybe being an issue, Dyson responded by looking at designing a new ventilator. So within 30 days of starting a project, they'd kind of designed a working ventilator. I think that's fantastic. Like, to go from, if you know anything about the medical field of engineering, things often take quite a long time. There's a lot of kind of processes, whereas to kind of develop something within 30 days is fantastic. And it was design engineers that were working on this project. So it's the kind of thing that I could have been working on had I been at Dyson at the time. So I think that's really inspiring. And it's great to be part of an organization where those kind of things happen. A big problem arises, and engineers and kind of people step up to try and solve the problems, real world problems. So that's really cool. Part of the reason that I love being part of Dyson. So I work specifically in the kind of environmental care sector. So looking at kind of like the air purifiers. And one of the cool things about working in this kind of area is, for example, air quality. Air quality is a big issue that's of growing concern. Again, COVID's kind of highlighted this, and only last week, the BBC put out an article that said that toxic air puts 6 million at risk of lung damage in the UK. So clearly, it's something that's becoming of greater awareness as we're presented with kind of some of the problems we face today. So it's really cool to think that the work that I do and other engineers at the company, we're looking at improving the health of people's lives while they're in their kind of home or indoor spaces. So it's really cool to be kind of positively contributing to people's lives and quality of life. Kind of aside from that, and again, touching on sustainability, as some of the other companies here this evening have done, sustainability is something that's definitely kind of big and definitely growing. And within Dyson, it's really cool to see things like the James Dyson Sustainability Award. So this year, the winner being the kind of idea of turning waste crops turned into material that generates electricity from ultraviolet light. So that's kind of shows that it's the kind of place where sustainability is taken really seriously. And myself, I did an internship a couple of summers ago, and I was looking at sustainability while I was on my placement. And it's really cool to think that at such an early stage of your career, you could be doing things. I mean, a company like Dyson produces millions of products that have plastic in them. And if you can make sustainable improvements to these products, the impact you can have is monstrous. It's crazy. So it's so cool to think that you can kind of go from a university environment into the kind of out into practice and suddenly be causing big changes. And I know I studied design engineering as well, so I know what it's like, and it's really cool to think that you could be making those sorts of changes when you step out the door. So I've loved being at Dyson for the 6 months that I've been here so far, and really kind of excited to be here for longer. And I know that kind of it's definitely somewhere that I'm sure all of you would really enjoy too. I know that Dyson's looking for kind of innovative, creative, and people who are really curious to learn, curious to kind of break stuff, make stuff, and try things out. So if you want to know more, chat to me in the breakout room later, and we can kind of talk about what it's like at Dyson. And Katie from Early Career is going to be there as well, so she can answer some questions about that. So look forward to speaking to some of you later. Thank you very much.
Thank you, Jack. Thank you for your speech. I truly agree with you. I think curiosity is a great source of really good new ideas. And Dyson seems to embody and encourage curiosity. So I'm sure a lot of our soon-to-be graduates will be interested in that. Thank you very much for being with us today.
No problem.
So with that, we have concluded our keynote speeches for today. thank you once again to the companies that not only gave keynote speeches, but also to the companies that are waiting for us in the breakout rooms. I wanted to say that this is a wonderful opportunity for students and companies alike. Oh, sorry, I have forgotten one more talk. My apologies. That does not conclude the speeches for today. We have one more speaker. A final speaker for the evening is David Sharp from Ocado Technology. He is the head of technology 10X. My apologies, David. I got a bit overexcited. It is a pleasure to have you here. And I'll just mention really briefly for those of you that don't know, Ocado Technology develops robotic systems, warehouse technology, and software technology for grocery e-commerce. So the floor is all yours, David.
Great, thank you very much. Okay, so welcome to the Ocado 4.5 minutes or so. So I'm David Sharp, I'm head of Ocado Technology 10X. 10X is about making radical change to the way things are done. If you want a job at Ocado, you can go to jobs10x.oca.do. Good luck. Okay, so some numbers to start with. An introduction to Ocado Technology, then I'll talk about some of the robotics that we're up to, and then finally, what do we want from our design engineers? So Ocado Technology is a world-leading innovator in e-commerce, robotic warehousing, and smart logistics. We've got over 2,000 engineers for you to join, and they cover almost all the engineering disciplines: design, software, electronics, mechanics, robotics, and data science, and machine learning. Lots of good stuff. We use lots of artificial intelligence and robots, simulation, digital twins, where you have the software and the hardware working in sync with each other, Internet of Things technology, and lots of clouds from Amazon and Google and Microsoft and anybody else's clouds. We've just grown this year. We now have 11 development centers. We've got Hatfield and London. In Poland, we have Krakow and Wrocław. We've also got one in Barcelona, one in Sofia, one in Stockholm. And this year we've added development centers in San Francisco, Toronto, and Las Vegas. So there's lots of cool places to go. We offer over 20 internships a year for undergraduate and PhD students, either over the summer and also as 6-month placements, like for design engineering. And we've also got graduate design engineer roles in robotic systems design. So apply soon at jobs10x.oca.do. Now, meanwhile, your colleagues will be building 54 robotic warehouses around the world. And we've now got clients in Europe and America and Canada and Japan and Australia. So we're busy building warehouses. And in the UK, we've got 3 big warehouses, and we're building 3 more for next year so that Ocado can keep growing. So this is a massively expanding technology business. In the UK, Ocado Retail, so those are the vans you see outside Imperial driving around, this year achieved £2 billion worth of sales, shipping 330,000 orders per week. And with 60 items in each order, that means we have to pick 20 million items per week. And this is rather challenging. And so as well as having humans doing it, we're having robots doing the picking as well. So there's plenty to design there. The catalogue is got about 54,000 items in it. So it's massive, about twice as much as you could get in the biggest supermarket in the UK. And yet we managed to fulfill orders with 99% accuracy. And we have hardly any waste, only 0.04% waste. Because some members of my team created some neural networks that could predict how much we were going to sell each week, and we managed to get the waste down. So there's some numbers. Now, if you're operating the retail business, you have to deal with about 47,000 orders every day. You've got a load of vans, 2,000 vans or so, and each van will drop about 20 to 25 orders each day. And these have to be dropped in 1-hour slots, but there's a van weight limit and there's a van volume limit. And so you have to optimize what happens. Okay, so we have to do about 600,000 routing adjustments per second, so we get all the vans going into the right place with the right groceries in it. And we use the little vans that you see around. We also use enormous vans to get lots of food, for example, from London up to Leeds or Manchester or further afield. And we're gradually building our fleet of electric vans, which are these Blueberry vans down here. And who knows, maybe next we should be looking at autonomous vans in order to further robotize everything that's going on. So that gives you an intro to the tech. What about robotics? What do we do? Well, we're famous for our new warehouses where we have lots of washing machine-sized robots that move around on the top of a metal grid, picking up boxes of grocery underneath. And they drop those groceries down so that people like this lady in the bottom right here can pick groceries from the left-hand side where there's white boxes and transfer them onto the right-hand side where there's red boxes. This system contains the densest mobile network in the world, with 1,000 robots per base station and 3 kilobits per second to each robot, talking to the robots 10 times a second. And the robots travel at nearly 10 miles an hour and pass within 5 millimeters of each other. So it's a jolly exciting thing. And here's a little video of the whole thing operating. So here you can see lots of robots with a proprietary radio communication system, some brilliantly design engineered wheels and software, and electronics and hardware. So it's an example of the sort of stuff we get up to at Ocado. And we also use robots for picking. And so here you have to, the goal is to pick 50,000 different items using computer vision and machine learning in order to dip your robot arms into these boxes of stuff to pick them up. We've done some projects on soft manipulation of things like fruit, and also on making humanoid robots. So maybe one day they can help deliver things to your house. So what do we want from our design engineers? Well, we're looking for technical capability in design, user interfaces, software, electronics, mechanics, and robotics. Innovation capability. Can you generate new ideas, new designs, new systems? Enthusiasm, energy, and can you work in a team? So do you show some autonomy? You can do things by yourself. Some collaboration, doing things in collaboration with others. Craftsmanship. Are you a brilliant design engineer? Do you learn fast if you get things wrong, or if you want to iterate things? And finally, can you be trusted to deliver, or if you get out of your depth, to ask for help? So there we are, Ocado Technology, an exciting place to work. Thanks very much for having us.
Thank you so much for being with us, David. That was fascinating, and I think definitely our students are very well trained and suited for their company, with a strong background in robotics as well as creativity and testing our ideas very quickly. I think we have a perfect match. Thank you again for being with us, and it was a pleasure hosting you. Great way to end the talks. So this time, so we have concluded the keynote speeches. Thank you again to the companies joining us today in the keynotes. I would like to highlight and remind everyone that the companies that have given keynote speeches are not the only ones that will be present. We have many more companies in the Teams channel. Each company will have their own channel that the students will be free to join. And the companies here present at the keynote speeches will be joining their channels as soon as we conclude this stream as well. So for the second half of this event, we will be moving on to networking, where both the students and the companies will be able to have more personalized one-on-one conversations. The companies can expect questions from the students on the types of roles they have open, the types of skills they're looking for, and just about the company's work in general. And we have posted bios of the companies on each of the channels for you to see. So we will be moving to the Teams channel in a bit. Max, Pooja, and myself will be ensuring in the next couple of minutes that all the companies can successfully enter their channels. So that will be maybe 1 or 2 minutes. So apologies if there's any slight delays with that. So with that, I would like to thank again the companies and the students. And it has been a great pleasure hosting you all. And I shall see you in a few minutes in the Teams channel. Thank you very much. Have a great evening.